8.2 times. Today we're looking specifically at arithmetic sequences and partial sums. So same type of information as last time, but specified to an arithmetic type sequence. So you want to be able to recognize when a sequence is what's called arithmetic. Find partial sums of those types of sequences, which involve a new formula. And that's basically what we're doing. So, what is an arithmetic sequence? A sequence is arithmetic when the differences between consecutive terms are the same. All right, so what that means is when I take term 1 and term 2, subtract them from each other, that will come out with the same difference as if I took term 3 and term 2, or term 4 and term 3. So any consecutive two terms, if I subtract them from each other, I'll always get the same common difference, which is represented as a D difference. So that alone specifies a sequence as being arithmetic. So let's take a look at one that we have here. A sequence whose nth term is 4n plus 3. Let's see if this is arithmetic. Well, first I need to figure out what some of the terms are. So if I look at the first term, the first term, it's going to be 4 times 1. This is going to be term 1. 4 times 1 plus 3, which is 7. And then the second term will be 4 times 2 plus 3, which is going to come out and give me 8 plus 3, 11. And the third term, 4 times 3, again plus 3, 12 plus 3, 15. Now, I have three terms. I don't really need to go any farther. I want to see if when I subtract the terms from each other, say the third term from the second term, what do I get? 15 minus 11, that gives me a 4. What about when I do 11 minus 7? That also gives me a 4. Wow, it looks like I'm having the same common difference, or D value, of 4, which tells me that this sequence is in fact arithmetic. And it's that simple, folks. Cool, cool. Alrighty, next one. 7 minus 5n. Is this one arithmetic? Well, let's check out some of the terms. Let's go for the first term, a sub 1. That's going to be 7 minus 5 times 1, which is just going to yield me a 7 minus 5, which is 2. And then my next term is going to be a sub 2, which is going to give me a 7 minus 5 times 2, which will yield me a negative 3. And my next term, a sub 3, will give me 7 minus 5 times 3, which is going to be 7 minus 15, which is going to give me a negative 8. Now let's see, what kind of common difference does it seem like we're getting here? We got negative 2 to negative, positive 2 to negative 3. That's a common difference of negative 5. It's going down negative 5. And then negative 3 to negative 8, again, that's a common difference of negative 5. So it looks like I'm getting the same D value of negative 5, indicating to me that this sequence is in fact arithmetic as well. If these numbers were not the same, that's when we get a sequence that is not arithmetic. Alrighty, so an arithmetic sequence is always written in this basic format. The sequence itself, a sub n, will be written like this. The first term, a sub 1, plus n minus 1 times that common difference. So as long as you have the first term of the sequence and the common difference, you could create the expression or the equation to show that sequence. Alrighty? So let's take a look here. There is a formula now for where we can find partial sums of arithmetic sequences. Before, when we were doing sums of sequences and partial sums of sequences, we had to plug in the values all the way up to the partial sum. Now that's not a big deal if our partial sum is, say, something like the 5th partial sum or the even 10th partial sum. But what about if you wanted your partial sum to be like the 150th? You're not going to want to sit there and plug in a sub 1, a sub 2, a sub 3, all the way up to 150. It would be absolutely crazy. So when we have an arithmetic sequence, we actually have a formula that we can use for any finite partial sum, which is going to be that series, that partial sum, equals the n value, so the sum you want to go up to, over 2 times the first term plus the last term. the last term of the series. So really all you need is the first term, the last term in your summation, and then the amount of terms in your summation. First term, last term, amount of terms. Let's see it in practice. I want to find the sum of all of these numbers together. Now yes, it's very simple. I could just add them all together, but we want to use the formula. So what we have in our formula is n over 2, which is going to multiply the first term plus the last term, and that will give me my summation. Now I need to know how many terms there are, the first term and the last term. So in total there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. 10 over 2 times the first term, that's a 1, plus the last term, which is a 19. Looks like we're going to get some nice numbers going on here. 10 over 2 is simply a 5, and 5 times 20. Easy enough. My summation is 100. Do we get how the formula works? Good. Alright, the sum of the first n terms of an infinite sequence is called the nth partial sum. The nth partial sum we found by using the formula for the sequence. So now let's find a bigger one, the 150th partial sum of this arithmetic sequence. Now, the difference between this and the last one is I don't know the 150th term. For my formula, I need the number of terms over 2 times the first term, a sub 1, plus the last term, a sub n. So I need to do a little bit more work on this one. First of all, let's try and figure out the formula for this sequence, right? What is my common difference that I have going on here? I go from 5 to 16, so that looks like a difference of 11. I go from 16 to 27, that's again a difference of 11. So my d value equals 11. And remember, if we went all the way back, I had a specific type of format that all arithmetic sequences followed. Right? And that particular format looked a little something like this. The sequence itself equals the first term, a sub 1, plus the d value, which multiplies n minus 1. So I have everything there I need, that the sequence will be equal to 5, the first term, plus the d value, 11, times n minus 1. Perfect. Now I can use this formula to figure out what I need for my summation formula. Now I need the 150th term. So let's take a look. A sub 150 will equal 5 plus 11 times 150 minus 1 is 149. Now that number should simply evaluate, and I can get a nice good piece in. So my 150th term evaluates to 1644. Coolio. Now that's only the 150th term. That's not the summation of all terms up to the 150th term. That summation comes from here. So how many terms am I looking at? I'm looking at 150. That's my n value over 2 times the first term, 5, plus the last term, which is 1644. And all of this together equals my summation, my partial sum, my 150th partial sum. Alright, so actually evaluating all of this stuff is going to get me 100,203 675. Very big summation. But that's how you do it. So we have a couple of things going on here. We have how to make the arithmetic sequence given just a little bit of information. We find it there. We have evaluating the sequence to get the 150th term. And then we have finding the summation all the way up to the 150th term, given the information we have. And that's it for this lesson. Write down any questions that you have. We'll do a whole bunch of problems in class, and I will see you then. Peace!